Welcome to the 10th video. We're almost there. This is using the binomial theorem to find a specific term in a polynomial expansion. We're going to review the binomial theorem and Pascal's triangle. We're going to find a specific coefficient for a specific term, and then we're going to actually find the specific term. In the last lesson, we learned that the binomial theorem is related to Pascal's triangle. In fact, you can use Pascal's triangle to find the coefficients in a binomial expansion. And we can see right here that we have the Pascal's triangle here. We also talked about how you could determine each of these numbers by using combinations. We said that this had two places, right? And so this is the same thing as one object taken 0 at a time and one object taken 1 at a time. Remember that this over here is just the alternative way to write the combination of 0 objects taken 0 at a time. So, and it's a little easier to write. So over here, we can see that this here has 3 terms. Right? So this is a plus b to the second power because to the second power has 3 terms, numbered 0 through 2. A plus b, or some binomial to the fourth power, or excuse me, third power, and I know it's third power because it's the same power as this second number in here. Each term is numbered 0, 1, 2, 3. 0, 1, 2, 3, 4. So if I wanted to find a plus b to the fifth, if I wanted to find the third coefficient for a plus b to the fifth, then I would find these coefficients. So I'd have 1, 5, 10, 10, 5, and 1. This is the 0, 1, 2, 3, 4, 5. So if I want the second term, r would be 1. So I would find the combination of 5 terms taken 1 at a time, and that would equal 5. So how many terms does x plus y to the 8th power have? Well, if n is 8, then the terms, the number of terms, would be 9, or n plus 1. So what is the coefficient for the second term of x plus y to the 8th? That should be to the 8th. All right, the second term, right? So if the term says second, what I want, the coefficient, what I want is the combination of 8 objects. The second term will be 1, taken 1 at a time. The second term of x plus y to the 8th is 8. Remember that it's n factorial over r factorial, n minus r factorial, unless you just happen to know the pattern. So what is the coefficient for the 7th term? Well, the 7th term is the second to the end, so this would be the combination of 8 terms, right? 8 terms, x plus y to the 8th, and then subtract 1 from the term number, that would be 8, 6. So that would look like this, which would look like 8 factorial over 6 factorial, 2 factorial, which would be 8 times 7 over 2, which is 28. Find the coefficient for the 5th term of a plus b to the 7th. Well, I want the combination of 7 terms. If it tells me, it's to the 7th power, n is 7. And then the number down here, r, is going to be 1 less than the given term. So this will be 7, 4. That is 7 factorial over 4 factorial, 3 factorial, which is 7, 6, 5. 4 factorial cancels, 3, 2, 1. So that is 35. So the coefficient for the 5th term will be 35. And we have to remember, because when you number the terms, you start with 0, so that you can end with 7. So there's 8 terms, right? But they're numbered 0 through 7. So the 5th term 1, 2, 3, 4, 5 would be this number right here. So, you know, I've been talking about the binomial theorem, but I haven't actually written it down or defined it. So on this screen, I wanted to show you a concrete example. This is x plus y to the fourth power. And remember that we get the coefficients from the combinations. So this is 4. This is the binomial theorem down here. So this first one here, to get it, is I would take 4, the combination of 4 objects 0 at a time, which is 1. And you can see there's a 1 there. X to the n, so that's the same power, y to the 0. The next term is going to be n objects, or 4, taken 1 at a time, which is 4. And then the next term is n minus 1, which is 1 less than 4, which is 3. This is y to the first. So you can see here as you're counting, y to the 0, y to the first, y to the second, y to the n minus 1, almost done, y to the n. And then if you start on this side, down here, y to the n minus 1, y to the second, y to the first, y to the 0. Here you start with 0. You take n objects 0 at a time, n to 1, n to 2, 3, 4. And this is how, this is written down in notation, this is the binomial formula. Now, how this relates to the Pascal's triangle is that you can get the numbers from Pascal's triangle either using Pascal's triangle or these combinations. So the binomial theorem can be summed up by this formula right here. Because the binomial theorem is a series, you notice that all the terms had a plus between them. So they're a series that can be written with the summation. So the sum of from 0 to n, the coefficient is found by finding the combination of 0 to k, or n to k, and then the first term, the letter would be a to the n minus k and b to the k. And so this is a general binomial formula. In your book, this is what it looks like. So it uses n objects r at a time, a to the n minus r, b to the r. R, in this particular formula, is the term you want to find minus 1. And that's because you are numbering from 0 to n. So like the fourth term is actually the third in this series because you start at 0, 1, 2, 3. That's the fourth term. So here what I want to find then is I'm going to use this formula to find the fourth term of a plus b to the 10th. All right, so I have n is 10. R in my formula is 4 minus 1, which is 3. So I want to find the whole fourth term, so I'm going to do 10 objects taken 3 at a time. The first term is a to the n minus r, which is 7, b to the r, which is 3. So, you know, because this is to the 10th, these two coefficients have to add to 10. So I just need to find 10 factorial over 7 factorial, 3 factorial, which is 10, 9, 8. The 7's go away, and then 3, 2, 1. So that is 12 times 10, which is 120. So my term is 120, a to the 7th, b to the 3rd. Okay, find the fifth term of x plus 3 to the 7th. We're going to do the same thing. N is 7. R in my formula is 1 less than the given term, so that's going to be 4. So I'm looking for 7 objects taken 4 at a time. The first term is n minus r, so that'll be to the 3rd power. And the second term, which is 3, is going to be to the r power. Notice these two add up to 7. All right, so then I find the combinations. So 7 factorial over 3 factorial, 4 factorial, which is 7, 6, 5. The 4 factorials cancel, 3, 2, this cancels, so this is 35. So put it all together, 35 times 3 to the 4th, x to the 3rd. 3 to the 4th is 81. So 81 and 35 is 2,835. Aren't I amazing? x to the third. I just happen to know that, 81 times 35. So, you know, if you have to use a calculator, I understand, but we need to work on our, you know, mental skills and all of that. Anyway, on to the next. X plus 8 to the 10th power, find the fourth term. So that's what n equals 4 means. So I have n is 10. In the book, this is how it has it in the book, n equals 4. What it means here is find the fourth term. It's confusing because they use n, the same letter as in their formula, but that's what they mean by that. So n is 10 still in my formula because I have n over r, whoops, I always do that, nr, a to the n minus r, b to the r. Okay, so I have r is going to be 3, so I'm going to have 10, 3. Then I have the first term to the 7th, the second term, which is 8, to the 3rd. These two add to 10, so I'm good. And then I have 10 factorial over 7 factorial, 3 factorial, which is 10 times 9 times 8 over 3 times 2. So 3 goes in here, 3, 4, so that is 120. So I have 120 times 8 to the 3rd, x to the 7th, and that's going to give me 61,440 x to the 7th. Once again, amazing mathematical ability that I can multiply 120 times 8 to the 3rd. Okay, so anyway, that is the fourth term of x plus 8 to the 10th power, if I multiplied that all out. Okay, I would like to talk about these last two. These last two problems are just a slightly different way of asking the same thing. It says find the coefficient of x to the 10th, y to the 5th in the expansion of x plus y to the 15th. Okay, so I know that n is 15. That part I know. I also know that this one is n minus r. So if I know that, and then I also know that this 5 is r. So to find the coefficient, I would take 15 objects, 5 at a time, right? And so it doesn't ask you to find the whole term, it just asks you to find the coefficient. So this is 15 factorial over 10 factorial, 5 factorial, which is 15 times 14 times 13 times 12 times 11 over 5, 4, 3, 2, 1. So that's 15, and 4 goes into 12, 3, and 2 goes in here, 7. So when I multiply all of that out, I'm going to get 3,003. And that is the coefficient for this term right here. All right, so find the coefficient of x to the 10th in the expansion of x plus 2 to the 15th. All right, so this time what they're telling me is since this term is a number, then the coefficient is, I'm actually going to need to write the whole term. So I know that n is 15, so I have 15. The coefficient of x to the 10th, that means that r is going to be 5, because this 10 is n minus r, so this will be 5. Okay, and we just did that one right above here, so I'm going to use my deductive abilities to know that 15 objects taken 5 at a time is 3,003. Okay, but the other thing I need to know then, 3,003, x to the 10th, and then this number 2 to the what? Well, remember that these two have to add up to 15, so this is 2 to the 5th. So what I really need is 3,003 times 2 to the 5th, which is 32, which is 96,096. I know, brilliant. You just can't understand how I can do that without a calculator. So we're going to do a lot more of these in class, but I think you're starting, once you see a few of these examples, it's not really a big deal. It's kind of like a big puzzle. You just have to figure out what information you've been given and what you can use, and then there's a formula. So I will see you in class.